Hi, everyone. Welcome to the session. So my name is Rong, and I am a PM on the Visual Studio C++ team at Microsoft. So our team owns everything developer tools for C++. So we do own the compiler, MSVC, the libraries, the IDEs, including Visual Studio and Visual Studio Code. So myself, I've been focusing on Visual Studio Code for C++ in the past year. So really happy to be here to share with you what we have got in Visual Studio Code for C++ development. So just a quick show of hands, just so I know. How many of you have already used Visual Studio Code for C++ development? Okay. Majority, 60% probably. Hi, welcome.
Microsoft Visual Studio?
Visual Studio Code.
Code, yes.
For C++?
Yes.
Okay, good. All right.
Well, mostly for TypeScript, but.
Okay, but you have used it for C++ too. Okay. Yeah, so for those of you who haven't tried, I will show something really simple, easy, and to get you started. And for those of you who have tried, I'm going to show the latest version of Visual Studio Code C++ extension that we just shipped this week on Tuesday. So everyone is going to see something new that you haven't seen before. My agenda is really simple. We're going to do a quick introduction to Visual Studio Code, and then we're going to spend majority of the time doing demos, and we'll do a summary at the end. So first of all, the Visual Studio product family. Many of you probably are familiar with some of these products, but there are some other products. We count everything as the Visual Studio product family. There's Visual Studio IDE, which is a really rich, featured, full IDE that has everything, literally everything, from platform support to functionality, from testing, deployment, debugging, everything there, profiling. And Visual Studio Team Services is our developer services, which helps you to build your code in the cloud, cloud building, managing your work items, including bugs, continuous integration. It does work with Git as well, so bunch of services. And Visual Studio Code is our cross-platform, lightweight editor that we're going to focus on today. Last but not least, Visual Studio App Center, which is another set of developer services that focus on production diagnostics. You can get analytics, you can get crash reports, and stuff like that. So for this talk, we're going to focus on Visual Studio Code. Really quick. It's a lightweight editor, but really powerful. It runs cross-platform, Windows, Linux, and Mac. It's completely free and it's open sourced. It has built-in support for JavaScript, TypeScript, and Node.js, but many other languages are also supported through extensions. So there's C++, which is the one we're going to talk about today, but there's also other languages that's well supported, including C#, Python, PHP, Go, and many other languages through extensions. Completely extensible and customizable. Yes?
So just to understand, this is basically just a code editor.
Yes. So the question is, this is basically just a code editor. And the answer is yes. It is meant to be a lightweight code editor, but it does have a very lightweight basic debugger built in as well, which I'm going to show you in the demos. Last but not least, it has built-in Git integration, which I'm going to show. Yes, question?
You said it's multi-platform. Is it written in Java?
The question is, you mentioned this is cross-platform. Is this editor written in Java? It's not in Java. So this editor itself is based on this technology called Electron. And some of these components of VS Code is actually written in JavaScript. All right, so just a quick introduction on the C++ extension for VS Code. This extension, which is what our team focuses on, enables C++, C and C++, IntelliSense, co-browsing, and debugging. We shipped it roughly around 2 years ago. It's got over 7 million downloads to date. So let's switch over to a different machine and start doing demos. So
Bad idea.
Huh?
Bad idea.
Bad idea to do challenge on stage? Yes.
Bad demo, they always go wrong.
Yes, I know. See what I set myself up to. But I'm gonna do it. Let's. Yes.
Is there any reason that the other machine is Mac?
No reason, because it runs cross-platform. I thought might as well show you on 2 different machines, just so you believe it actually runs on cross-platform. So everything I demo here on Mac, you can pretty much do the same thing on Linux. Very similar experience on Windows, of course, but I just picked Mac for no reason. Uh-oh. All right. And if you don't mind, I'm gonna sit down for demos. Okay, awesome. All right, let me get my timer started, and we'll see how long it takes. I said 20 minutes from scratch, right? All right, now it's starting. Okay, so here's Visual Studio Code, and I just want to show you one thing before I get started, which is if you switch over to this extension folder tab. This here is the Microsoft C++ extension for VS Code. That's all we need for everything I do today in demos. All right, so now let's go back.
Are the extensions also free?
Yes, completely free, and we also open sourced part of it. And I don't have time for that right now. Hold on to the questions. We'll get to that once I'm done. Okay, so by scratch, I really mean that, which means I'm gonna create a new folder here, has nothing in it. I'm gonna open that folder in VS Code, CPP now, and it's gonna show me a welcome page. I'm gonna close that, and literally there's nothing in here. Now, let's add a new file, do a very simple program. Notice as soon as I type in CPP, it recognizes it's a C++ file, which means our IntelliSense for C++ is going to start to kick in. Yes?
Does it work for CXX as well?
CX?
CXX.
Oh, CXX, yes. So we do have a list of file extensions that we associate with this extension. Yes. Okay, so with no configuration so far, I've simply created a new file. You're going to see we have IntelliSense support right away out of the box. Pound include, one thing we just added was the autocomplete suggestion for headers when you type in pound include. So I could do system headers, or I could do user headers by doing quotes. So that's just already there. Now I can type in with the help of IntelliSense all the way. We know what namespaces are available. We give you suggestions, and I can type in right here. Now I'm ready to write something in a main function, right? But I really don't feel like typing all that much. So what I'm going to do is to use another new feature that we just shipped, code snippets, which is available in Visual Studio as well, but we just added it here. Now I can select main. It's gonna give me the main body of the function, so I can start typing right here. So for this demo, what I'm gonna do, I'm just gonna do some math calculation, something really simple. Takes in 2 inputs, 2 numbers from users, and then generate all the prime numbers in between. Okay, so I'm gonna do enter 2 numbers, and you see the IntelliSense I'm getting as I type. And I'm gonna do 2 variables and taking those values. As you see, I have no error checking whatsoever, but I'm just trying to get something running real quick. All right, at this point, how about let's do a class that will basically be a calculate class that perform one of the methods it's gonna be performing, generating the prime numbers. So since I'm tight on time, I'm gonna use another code snippets. We have a couple of snippets for classes. There's one with inline constructor, destructor. There's also one for class template. So I'm gonna use this one and rename this to calculator. And I don't care about anything else at this moment. I'm just gonna add function called prime generator, which takes in 2 integers, and be done with that. And now let's go define this method. You see the IntelliSense I'm getting here as I type in. It tells me this is the one I can need to define, and I'm going to pass in x and y. Oops. Y. See how hard it is to type on stage. Okay, so now I'm going to do a for loop real quick. Again, I'm going to use a snippet for a simple for loop. I'm going to do int, and this one is going to be y, and I'm going to go back and do this one as x. Really, really simple. Now I'm going to need a nested for loop in here. And I'm going to just cheat a little bit. You don't think I'm actually going to type everything on stage, right? Do you? All right. Just do that real quick. So I found some code that can work, but it's badly formatted. And what I'm going to do is I'm going to go in here and select and right-click and say format this selection. So it's going to do the auto formatting for my code. So we do ship with a clamp format tool. That's what we're using for this feature here.
Is it configurable?
Configurable, yes. In what settings do you want to config?
Where to put, so code style, where to put the braces?
Yes. So we do have that in the settings. You can change that. We pick a default, I think it's a Visual Studio style, but you can change it to something else. All right, so another snippet to do if, and I think we are pretty close to being done here. And I'm going to do code, which is going to be just output I value. And that's it. And coming back to main, I'm just going to instantiate this calculator with C and call that function with x and y. And now let's get, just so we have the command line stop, so we can see what's being output. All right, I feel like we're done here. Any thoughts on running this? See if this will just work on first try.
Can you show it again? Below?
The which part?
Below.
Oh, below. We'll test it out. All right, let's see. So now I have got my code written. The next thing I want to do is to compile my code. So everything is driven by the task system in VS Code for building, for running any external tasks. So what we're going to do is go to Tasks menu. It has Run Build Task. So if you do that for the first time, you're going to have a selection that says you need to config the task because we have not set it up from a template. So there are a couple of templates that the VS Code ships with, but we're going to go ahead and do the others. And this is very, very straightforward. All I have to do here, it's a JSON file, give it a name. The task needs a name. And you can then pass in any command you want VS Code to run as part of the build task. So on this machine, I have GCC installed, which is the compiler I'm going to use. So one thing to mention is VS Code does not ship with any C++ compilers. It's up to you to select which compiler you want to use. But it also means it's really flexible because you can call any compiler from here. So for example, I can do G++, and I pass in -G just so we have the symbols generated because I'm gonna do debugging afterwards. But then that's basically it. Then CPP and output is gonna be a hello world file. Save that. One more thing I want to do, it's optional, but I usually do that, is just to make sure this is my default build task, because I can have multiple build tasks. And if you want something default, that means you can simply run that from here, run build task. So it knows this is the default one to call. All right, let's run that. All right, so VS Code comes with an integrated terminal, which then shows us the output. This is calling the command I asked it to call and returned a warning. So this is one warning here, which is not too bad, but if I got tons of warnings here, it's going to be really difficult to read. So for that purpose, we're going to enable another thing in the tasks, which is what we call problem matcher. It's nothing but regex definitions to tell VS Code how to interpret the returned warnings from the compiler. So we have one built in for GCC. That's what we're going to use. We're going to kick off this again. Same thing, but one thing you would notice is over here in the problems window, now we are seeing the warnings coming back from the compiler. So you kind of have the UI integration here. What's nice about this is now you can double click on the error, which is going to take you back to the source code. Okay, so what is this one about? Control reaches the end of non-void function. Oh, because I defined it as an int and I didn't return anything. I guess for here, I don't really need an int, just do a void. And in a second, you're gonna see IntelliSense kick in to tell me that there's a squiggle here that says my declaration is incompatible with the definition because I have different return types. Of course, I need to fix it in here as well. All right, let's save that and run.
Can you jump from definition to declaration right away?
No. Let's see. So I said that too early. So we have, I was going to show you that later, but we do have navigation features to take you to definition or declaration, right? But what you could do is when you are in the definition file, which is usually CPP, you can do switch to the header, the corresponding header file, which basically does kind of what you want.
If the cursor stands on the definition signature, you cannot jump to declaration level.
No, that's not something we have built-in support for, but you can kind of work around that with the switch header and source, kind of. Yes?
And how the editor knows in real time that you have errors? Does it run just your build or how?
Sorry, what? Can you repeat that?
How editor knows that you have a different declaration and definition without manually running build command?
How does so like the IntelliSense squiggle? How are we able to figure out its mismatch?
Yeah.
IntelliSense engine would index your code in the background. So in this case, even though we haven't configured anything, IntelliSense actually is doing work in the background. I'll show you how it works once I'm done with this. But it is a real compiler-based IntelliSense engine, which reads your code and have the understanding of your declaration definition, and that's how we did the navigation features. Okay, so we rebuilt and the problem goes away, so we're all happy. At this point, I already have my executable here, and I can simply use the integrated terminal in VS Code to run my app. All right, so right here, and I'll do hello, enter two numbers, 2 and 100. Uh-oh. Other than 2 and 3, the others don't look like prime numbers at all. All right, let's see how we can debug this. So coming back to my code, I wanted to be able to look into how this prime generator function was called and why it didn't generate the right numbers. So I want to put a breakpoint here. Now we're going to do debugging. So debugging in VS Code is in this debug tab. As you would expect, click on that button. It's going to start debugging. But then, of course, this is the first time we're running this. It just needs a little bit of configuration. So in here, I have the option of Node.js and C++ because Node.js is something that VS Code supports out of the box. C++ is the option that we bring in from the extension. So on different platforms, we support multiple debuggers. On Mac, we have LDB integration. If you're on Linux or Windows, you can use the GDB debugger. And on Windows, you have the additional option to use the Visual Studio Debugger. It's all fully integrated here. And just need a tiny bit configuration. Okay, another JSON file. It may look overwhelming at first, but really the only thing you need to do in here is to tell VS Code what program you want it to run, to launch. For here, I'm just gonna pass in the name of my program, that's all. Workspace folder is gonna be referring to the root folder I open in Visual Studio Code. In this case, there's only one folder, so okay. Let me save that and switch over to the file. Now I can start debugging. Now Visual Studio Code is gonna launch the debugger, load the symbols, and then launch my app in a separate terminal window.
One of the built-in terminal.
That's an excellent question. The question is, why not debug in the integrated terminal window? We have heard that a lot as requests, and that's something on the backlog we're going to work on in the future. 2 and 100. So we're hitting the breakpoint here, back in Visual Studio Code. Now you can look at your variable values by hovering over. Yes, another question?
Can you open the debugger configuration file again?
Yes.
Where the LLDB.
Yes. The reason I have this is because I'm on Mac. So it goes and provides me the template for LDB by default. Like
but
here.
you're compiling with G++, why don't you use GDB debugger?
I could.
Doesn't matter?
I haven't tried that,
Okay.
but I don't see why it wouldn't.
You should be able to. It just
Yeah.
depends on what kind. So, like, if you're using Clang, it outputs certain debug information that you might not be able to use automatically with LLDB. So we're just making a guess based on your operating system here.
Right. So
If
for
you're on
Mac, yeah, good.
Probably LLDB.
As a default options, that was all. Okay. Let's see where I was at. Okay, here. Or you can look at the variable values in the locals window. I can now step into the function. If I do that, oh, I was going to do step into, and then I click on the wrong button, of course. But you get the idea. Let's try again. Because I really want to see what's in that function. All right, now we can step over. Of course, now the value of I is 2, and it was correct because it would output just fine. And next loop, I is 3, and that was fine too. But the question is the next one, which is I equals 4, which is clearly not a prime number. And, oh, it skipped that if statement, which means we are not setting the value to false, which is why it got output. Okay, so looks like I'm doing something wrong in here, if statement. Let's try this. If it's 0, that means it's definitely not the prime number. Okay, let me save that. So at this point, we just need to recompile the code and rerun it and see if it works, right? One thing I often do is, at this point, I'm just gonna hit F5 and assume everything will just work, but that's not how it works in VS Code, because VS Code in the launch file, all we said was launch this program. It would not recompile. So what I always do, if you're kind of doing this development in VS Code, is to say, hey, before you launch my program, can you run this task? All I have to do is to say, run my build task, and I'll be done with that. Now every time I hit F5 right here, oh, let me remove the breakpoint. I don't need it anymore. It's gonna recompile. See the executing task there, and I don't ever have to worry about not being compiled, actually. And 100. Yay! Now we're getting our prime numbers. All right, very simple program just to show you what the experience looks like when you're writing code in VS Code. Okay, so I'm feeling pretty good about the program, what do you say? Can we ship that? I know it doesn't have any error handling or corner cases or anything like that, but I'm feeling good about shipping. How about let's add a license to the code? MIT sounds good? Sounds good? This is my favorite part of the feature we shipped this week. Is a code snippet for MIT license. That's all I need to do. See? Even has placeholder for year and name. Perfect for what I need now. All right. So that's code snippets. And last thing I want to show you is the Git integration. So now I have my code under a license. I'm going to share it with someone else on GitHub or something, and other people are going to contribute. We better have this under a source control system. And VS Code has that built in. All you have to do is to come here. This is the Git tab. And initialize the repository. And pointing to this folder, which is fine. It's going to list every single folder, every single file in that folder. What do we want to have under source control? Source code and probably the JSON file, so other people can use it. So what's nice about having this in VS Code control is now if I make a change in the code, VS Code is going to detect that and tells me this file has been modified. Now if I click on this file, it's going to bring in the side-by-side view to show me what has been changed. So everything you can, from writing, building, debugging, source control, everything that you can do in VS Code without having to leave the editor. All right, so I think I'm done with this one. 20 minutes exact, but I have to minus all the questions you guys asked. But still, yes?
Have you tried cross-debugging?
Cross-debugging, what do you mean? Oh, sorry. The question is, have you tried cross-debugging? Can you clarify that?
I have a device connected to my PC, and there is it's constrained resources, and it's running GDB server, and on my PC, GDB debugger connects to that GDB server and do debug. If I want to do the same within this IDE, is it achievable?
Yes, I believe so. I haven't tried that myself, but I have a coworker who is focusing on embedded development. He was telling me that was doable. We probably should do better documentations around how you can achieve that, but I believe that is doable. So we can follow up offline, and I can get you connected and figure out how exactly to do that. I don't have that set up right here. All right, so that was my first 20-minute challenge demo. So now we have seen how it works with a very, very simple program. Let's try something more complex to see if it works with real-world apps. Let me close this folder. And I'm going to open another different project. So what I have here, Box 2D. I can show that real quick. I got the source code from GitHub. It is a 2D physics engine for games. Has C++ code in it. And I simply just download, clone the repo, and open the folder on VS Code. Yes, you could do that as well, since we have the Git integration. So yeah, I should probably mention that you can directly run Git commands in here in the integrated terminal to get the source code downloaded. I don't have the machine connected to internet, so I can't do that right now.
Integrated like in the Visual Studio extension.
In the Visual Studio.
There's an interface for clone and everything else.
Right. So there are some Git commands that have UIs in VS Code 4, like push, sync, commit, stuff like that. But there are also commands that you just need to use the command line directly.
There are also more extensions for Visual Studio Code, which give you finer control over how you use Git.
Right. Is it the Git Lens?
Git Lens is a very popular
Yeah.
one. I'm not exactly sure if it's featureless, but it is widely used.
Yeah.
There you go.
All right. So let's take a look at this project. Let's open some folders. So it has a bunch of folders and subfolders and contains CPP and header files. It's a pretty well organized, self-contained project, meaning everything it needs is within the root folder. It doesn't have any external dependencies. So let's see what the experience is going to look like if I just randomly open a file in VS Code. No configurations has done so far, right? I simply just open the folder. And one thing you will see here is for a complex project like this, you still get IntelliSense out of the box with no configurations. By IntelliSense, I mean multiple features. So first of all, you can hover over any functions to see what we call a quick info tooltip to show you the definition. We do what we call reference highlighting. So if you click on a symbol, it's going to highlight all the occurrences of that symbol in that file. If you start typing, let's see, you kind of have seen that already in the first demo, but this one is going to show me all the methods I can use. Clone. If I do parentheses, we show you what type of the parameters you should put in here. And if I just close it with nothing, IntelliSense is going to red squiggle that and tell me, hey, you have too few arguments in this call. So I get IntelliSense support all around. Other things we support is what we call code navigations. So a lot of times when you look at projects that you didn't work on, or you look at someone else's code, you want to understand how code works. So you want to be able to see the definition or declaration of functions and stuff like that. So you could simply right-click and use one of these things. Go to definition, peek definition, we could do, let's say, peek. The difference between peek and go to is instead of opening a file separately, this is going to bring that file into the context of your current file in an embedded window. So you don't have to leave the context of your current file. So that's that. That's the peek definition. Other things you could do is like you could just hold the command key on that. So it becomes a link. You can simply click on that, which does the same thing, takes you to the definition. We could also look for symbols or files in VS Code. Let's say circle A is a B2 circle shape, and we know that. We can simply highlight that and do Command T on Mac. It's going to search. What this is doing is it's searching throughout the entire workspace for all the symbols available in that workspace. So now I get everywhere B2 circle shape is showing up. I can click on that. This is the header file, and simply do switch header source. It's going to take you to the corresponding CPP file, just like that. All right, so that's some of the IntelliSense features you get out of the box. I'm going to explain a little bit how that works behind the scene once I'm done with the other parts of the demo. So we'll come back to this. But I want to show you how you can build a project like this, like go beyond a single CPP file. How do you build and debug in VS Code? So very similarly to what we have done in the previous demo is we're going to go configure task. I only have one. Very familiar, similar to what we had. And the only difference is instead of calling the compiler directly in the command, I'm using a script file, which is basically here, and it is really, really straightforward. This project is set up to build with Xcode on Mac. What I do in here is to say, just go into the build folder and use the Xcode command line tool to build this Xcode project. That is all. And you can simply ask VS to run the build task. It is going to call, oh, yes, one failed because I changed the code without actually finishing it. If I do that, it's going to succeed. But you get the idea. It's going to call the Xcode command line tool and build my project in here. Okay, so by using the task system, you can pretty much do anything in VS Code without having to leave the editor. Now let's do some debugging, very similar to what we did before. We can set a breakpoint in here and go to debug. And let me show you the configuration real quick. Really not that different from what we did before. Just tell VS Code where your program is. In this particular case, it's built and under the debug folder. And also you could specify the current working directory, which is what this project needs. So that's the only two things I did in this configuration, and I'm good to go. Let's go launch this app. Okay. So this is a Box2D test application. It has a bunch of shapes on the screen, and it's meant to test the collision between different shapes. So what we have set the breakpoint for is inside this collide circles function, which means when two circles collide with each other, this breakpoint is going to be hit. So let's try that. I have two circles on the screen, drag one, and make that go and hit. And we're back in Visual Studio Code. Very similar, you could do variables, but one thing I want to point out here is you can also do complex expression evaluation here, as two examples I have shown here, as well as multi-threading support. So out of the box, we do have multi-threading support for in the debugger. So in here I have thread one, but if you have multiple threads, you can view that too. Yes, question?
Do you have visualizers?
Visualizers.
Like for SDL?
The question is, do we have visualizers? No, we don't have built-in, like NetVis supporting Visual Studio, right? You are talking about. No, we don't have that yet. Go ahead.
You can technically put in NetVis files yourself. However, we integrate into visualizations for GDB, LLDB, because all we're doing is we're creating a pipe between the two. So it's just like if you're using those things by the command line, just presented in a very nice user interface.
All right. Yeah, multi-threading support is there. In addition, you could also, yes, a question here.
Sorry, I really like to see you peeking into a standard container and see how it unfolds. Can you just debug down a few lines? You got some vectors there, I guess, or some sort of vector. Is that?
Hang on, I'm gonna have to rerun this. Collide. Okay. Step over. What do you want to see?
I don't know what.
Like
I assume that's
like
some
a
sort of
P2.
container that you back to.
That's probably actually a real vector.
No, this one doesn't have. No, yeah, this doesn't have what you want to see.
But it's basically whatever you would see on the command line, right? So just because there's this thin layer that goes back and forth. So if you can configure this, pretty printing for GDB, there's no reason why you can't do it for Visual Studio Code, basically. So yeah, again, out of the box, it just depends on how you set up your build system and whether you made certain symbols available to your debugger.
Can you do some commands to a debugger in the command line interface? For example, show the step trace in the command line interface to the debugger.
So let me try to understand your question. So you're saying, can you run command line commands to the debugger in the command line interface? So what you could do is there are a couple of GDB commands we do support in here. So I tried the LDB example, it didn't quite work. But like for one example for GDB debugger would be if you run this, say want to see the information in the registers, that's going to show you all the data in there. It's like an assembly view that people have been asking for. So that would be one thing you could do, a debugger command you can run here.
Does the BT command work, that trace? It shows the step trace?
There's text traces on the call stack.
Right, so yeah, the call stack would show, oops, what did I open? Dictionary.
So
because I have that selected.
Only the commands that IDE supports can be entered in the command line to the debugger. Not any commands that the debugger itself supports.
Actually, I believe it's the commands that debugger supports.
you're
that everything.
GDB right there in terms
So
of.
can you
Yeah.
can you enter the command BT?
BT. You want to try that?
See that. Should be out.
I'm thinking. Oops. I haven't used BT myself.
Print a variable name, for example.
Right, but I'm thinking you need something to tell the command line tool that you are calling a debugger command. Like we need to prefix this with -xc in this example.
Can you show how it works?
I don't have GDB debugger set up on this machine, but maybe on
But this ID
the Windows
section
machine.
is using some other debugger underneath, right?
Yeah.
Yeah, but it's not, the process isn't attached to that window, I think.
Oh, there it goes.
Is it?
So you need to prefix with that.
Okay, there
I
you
think
go.
that's the catch. So when breakpoint is hit, you can do stuff like that to passing debugger command directly, but of course use with care. All right. Yes, one more thing I want to mention in the debugging experience here is we actually do support conditional breakpoint, and you can do logging as well. So you can pass in expression and tell it to break only when that is true. All right, now that's this demo. Now let's talk about what we do behind the scene to enable IntelliSense. Here's the real magic that we do, which is if I do Command Shift P, that is gonna just show me all the commands I can do to edit configurations. So by default, if you're happy with all the default experience you're getting for IntelliSense, you don't need to touch this file manually. But if you do want to change some values in here, this is what you need to do, is to bring up this file. By default, it's not created, but it's the same information we use in the background by IntelliSense. Okay, couple of things we do. One is this setting here that says compiler path. So what we do is we auto-detect the compilers installed on your system in those common locations. So for example, in here it's /user being clan. What we use it for is we then query this compiler for the system includes and defines. That's how we resolve your system headers, because we know where they are. So that's what we do for system headers. If you want to use a different compiler for some reason, you have different compilers installed on the machine, and you want to use a different one than the default one, you can change it here. Okay, so that's one thing. Second thing we do is how we resolve headers in your workspace folder. Like I have headers in subdirectories in many different locations. How do we solve that? So this is one of the new features we just enabled this week, which is the ** syntax. Meaning if you put ** at the end of any path, we're going to search your path recursively for anything available in your path. That's how we are able to solve all the header files in this particular case, because it's self-contained. It doesn't have external dependencies. That's how you can get the full IntelliSense experience out of the box with no configuration. Yes, question?
So with a single start, it will only be searching the files in this current directory without recursive penetration into the other side.
Correct. If you want to opt out recursive, just don't put stars. If you want it recursive, put 2 stars. So in the version that we shipped today, you might get slightly different experience because we didn't turn this on by default. So if you open a folder and you want it to perform recursive search, you want to come here and add **. But in the future, we're going to turn this on by default, so you don't ever have to touch this file. So that's 2 things, which is how we provide IntelliSense for this particular project. But you may ask, what if my project has external dependencies, external libraries I use? Which brings us to the next demo I'm going to show. So you may notice there's something other than the workspace folder path in here that where we search by default. This is the the VC package path. Anyone has heard of VC package or have used it? One? Okay. So VC package is a C++ package manager that runs cross-platform. It is in here actually on GitHub as well. Itself is open sourced, and it already has over 350 libraries, third-party open source libraries being supported already. It provides a really easy way to acquire those third-party libraries. And I'm going to show you that real quick in a different demo. Okay, let me close this one. Close folder. And this demo. This demo is really a simple application. So it has only one CPP file. What it does is it tries to render a triangle on the screen. But for that, it uses the SDL2 library, right? So it's a simple application that has a dependency on a third-party open source library. Now you can see out of the box, if you open that kind of project in VS Code, we are not going to be able to find it because you have something external to your workspace folder, and we don't know where to locate those headers. So this will be the default you will get if we are unable to find some of the headers, is we would green squiggle those headers we are unable to locate. This, you can read the message basically that says we cannot find SDL2 SDL.h file. And you get a message box that says, hey, you can update your settings to make full use of IntelliSense. Now, in this particular case, the only dependency I have is on SDL2. And what's the best way to get SDL2 on my box? What I did was using VC package. Let me show you that real quick. So in this blog post, basically we pretty much just announced the availability of this on multiple platforms like 2 weeks ago. And what you do is you clone the repo, the source code itself, bootstrap by running this script, build VC package yourself. Once you're done, simply run this command, VC package install SDL2. And it is available, like I said, over 350 libraries are available today, including many of the Boost libraries and other yes, question?
What's the process of, for getting a new library in there?
So the question is, what's the process for getting new library in there? That's a really good question. If you come here to our GitHub repo, there's a documentation detailing how you can do that, the process. I don't have the network connected, so I can't do that for you. But if you go back and search for VC package on GitHub, you can find it and you can figure out how to contribute. And we would love more contribution. Okay, so that's what I did for SDL2. And there's one more thing to do for VS Code to take advantage of VC package, which is to run this command, VC package install, integrate install, basically make VC package visible to VS Code so it knows where it's installed. That is all. But of course, you wonder why we still have squiggles. That's because I tricked the system by hiding it. Let's do that. So by default, VC package goes to your user folder, VC package, and installed. And I have the OS X version. You can see we have include folder, we have lib folder. We'll talk about lib later, but let's take a look at the include folder. I tricked the system by renamed it. That if I rename it back, now VS Code knows I have this library installed in this location. So it can use that to resolve our missing headers. And just come back, and I'm just going to reopen the folder file real quick, just make sure everything is kicked off correctly. Now the squiggles are gone because we are able to find the includes installed by VC package. Now I mentioned it not only comes with headers, but also comes with lib files, which means you can use the installation for building your app as well. Now, if you're using CMake, like how this project's set up, you need to run this command, basically make call this vc package.cmake definition, and that is all you have to do. And at this point, you can simply just run cmake and dot, cannot load cache. I don't know why. It's interesting. I've not seen that. Maybe I have to rerun this thing. Anyway.
Are you in build directory?
Oh yes, thank you. Thank you for that. I forgot. Yes, that's already built. Now I can run this from the command line. SDL demo. And we have our triangle using SDL2, the library I got on my machine. All right, so we talked about IntelliSense, how we resolve system headers, your user headers, and third-party libraries. And there's one more thing we haven't covered yet, which is now we know how to deal with single project. I finally have everything set up. Now I'm going to move on to a different project on my machine. Do I have to repeat the same process again? And we get that a lot. Is how do we share the settings across different projects? So in the latest version, we added support for global IntelliSense settings. And let me show you what we meant. Let me close this folder. And I'm going to open a different one. This is going to be in here. Another game engine called Atomic Game Engine. I downloaded from GitHub. It has a huge source base. You can go here, lots of subfolders. Let's say at this point, I am only interested in a subdirectory. That's all I work on for now, right? Instead of opening the whole thing, I just want to open a subfolder in there. So let's do that. Atomic 2D. And if I open a file, oh, no surprise, lots of green squiggles because it has references to header files lives outside of this particular folder, but it's in the parent folder of that folder. So now what I'm going to do is instead of trying to resolve this now, I'm going to add another folder to the workspace. So if you haven't seen this, haven't tried this in VS Code, it now supports opening multiple folders in the same instance. So if you work on multiple things that belong to different folders, you can do that as well. Add another folder. I'm gonna do app. How about app? And now I have a workspace that has two folders. If I open this file here, of course, this one has squiggles as well. Now I'm gonna try to resolve both at the same time by defining IntelliSense settings as workspace settings. So one thing VS Code has is it exposes many of the settings that you can change here. So if you go to Code Preferences and Settings, it has 3 different levels of settings you can set. User setting basically means it's a global setting that applies everywhere on your system per user. Workspace setting would apply to everything in this workspace. And folder setting, of course, is per folder. So you have different levels. Yes, question?
Where do you find the possible settings that you can use?
How do you, the question is, how do you find the possible settings to use? We have IntelliSense. See, IntelliSense everywhere. So if I come down here to workspace and I do quote, and if you are only interested in C++, that's everything you could do with the auto-complete suggestion. So to save the time, I'm just going to do a quick copy-paste to adding the setting I need.
You can also use the search bar up at the top, which will look through that file on the left for a particular.
Yeah, there's a search. Yeah, that's a good point. There's also search. You can type in and find what's there.
Very easy to set. You can actually take a look at the left pane, and then there should be a pencil icon which pops up, which will automatically populate your own setting.
Yeah. although this search setting here is gonna only find you settings you already have in this file, but these are additional settings that we don't populate by default. So by doing IntelliSense, you can kind of see what you could add. Okay, so if we take a look at this setting I just added, really, really simple. It says default include path, and I added the default, which is recursive search of everything in my folder, of course, as that's step 1, but also search everything under this folder. That would have everything I need to resolve the headers for those 2 project folders. Yes, question?
What's the workspace root if you choose 2 unrelated folders?
So the question is, what's the workspace root if you choose different folders? So workspace root refers to here, like the workspace level. And different folder is referred to as workspace folder. It's a different variable.
So it's basically a logical entity, it's not a physical entity of this workspace.
So the question is, it's a logical entity, not a physical entity. What do you mean by that?
Well, Atomic 2D and Atomic App are actual folders.
Right.
That I'm working from the, but
Right.
workspace root refers to
A higher level, yeah, it's a
conceptual-
logical concept that groups these folders together. And you can save workspaces on your disk. So next time you open, you can just open that workspace. It has everything in it already. Okay, so
Would it be relative to that workspace file that you saved? Then where, like,
so the question is, what you're talking about, the workspace file that I save?
the $ workspace root.
What does it resolve
That-
to, basically?
yeah.
Right, so that would be the workspace you save in here.
Yeah, but we haven't saved one yet.
Yes, we haven't saved one. Right now it's referring to this one, even though it doesn't have a name. There's a temporary version of that that's being referred to. But once you save that, you can save that anywhere on your disk.
Okay, so if we tried to use it, it would just be weird or something. Like it wouldn't work yet because we haven't saved the workspace. And then after we save the workspace file, it'd be relative to the workspace file that we saved, I assume.
Let me think through. So you're saying because we haven't saved the workspace, we can't quite use this variable.
Yeah, is it unentitled quote in strings, like, or star, random garbage? I don't know.
Sorry, I should clarify. This is not referring to the name of the workspace. So it's not going to be resolved as entitled. This is referring to, right now it's a concept, that's a virtual concept in here. If you look at workspace folder, that's going to refer to this folder in here.
Yes. But you're expanding a string right there in that file, and it's, I don't know. Anyway, it's,
If I understand correctly, workspace root / atomic 2D will always be the atomic 2D folder.
Right.
Atomic app workspace / atomic app will always be the atomic app.
Yeah, it's
folder, no matter where you put the file on the.
Sorry.
Yeah, go
so
ahead.
Wrong, you should be able to save the workspace as a file.
Yeah, yes.
Right, and then so that will then exist on the disk, and then
Right.
Basically Visual Studio Code will read that in and know to set up this particular workspace with the folders and the settings.
Right, but his question is, before we save it, where does it go? I haven't tried that.
because, like, I don't know, it can look at both the directories and go, hey, wow, this is the common root. I don't know, like, it could do magic for all I know.
Yeah.
Right.
But it could just pick the first one.
Yeah.
It could do it based on Atomic 2D, because that's the first one you made.
Yeah, so I think to clarify the situation, I think the use of workspace root here is a little like, we don't know where it's going to resolve to.
Yeah.
But to be more accurate, what we could do is for each folder, make sure you search recursively in everything in this folder. Like this is a setting is going to be applied to each individual folder when we actually resolve that.
So that then expands into 2 paths as opposed to 1, even though you only have 1
'Cause
comma
we-
there.
Right. Well, this is this.
Yeah,
Yeah.
a bit tangential.
Anyways,
I mean, if this is the place to ask those types of questions, though, right? I mean,
Yeah. So this is called.
Detailed-oriented.
Yeah.
don't sweat.
Yeah. So let me try to explain. So this is called workspace setting, meaning it's a setting that's going to apply to every single folder in the workspace. It's not a workspace level setting. So we actually take that, apply to each individual folder. So I think a better use of this here actually would be workspace folder. And that's like explicit about everything in this folder, search for that. Plus this additional thing you search for.
So
There's no workspace root that we need to resolve.
Multiple times,
Right,
and therefore you'll get multiple.
right.
All right, excellent. That makes sense.
So Ron, one more thing. If you hover over one of those, so like workspace root, does it display any documentation relevant to it?
If I hover over where?
Okay.
No, not. No.
Right.
There.
Let's move forward.
So, yeah, let's go.
Yeah.
Yeah.
All right, now let's go back. I'm gonna just reload the window just to make sure IntelliSense is kicked off. Now you're gonna see this flame icon we use to indicate the state of the IntelliSense. When it's going, meaning we are still trying to resolve everything. But when it's gone, that means IntelliSense is done resolving the headers. Now you see in this file, all the green squiggles are gone because we are able to locate all these headers. And if we switch over, and this is on fire, and it's gonna take a second to finish. And done, and no green squiggles. And what's nice about this global setting, what we call global, but right now it's workspace level setting, is now we can add more folders to this workspace. And those will get resolved using the same settings. So that settings is gonna be applied to this third folder. And out of the box, no more configurations other than the fire is gonna run for a little bit. And we're gonna see the green squiggles go away. And that's really nice because I have just do it once and apply everywhere in my workspace. If you want it to be global, just define the same thing in user setting. It's gonna go everywhere. Like if you have a common SDK or library, and you can put it in the setting. There, okay. All right, let's see, what else do I have here? Okay, now I'm gonna switch back to Windows.
Question.
Yes, go ahead.
How the number of files depend on the time for IntelliSense to process our headers, to find our headers?
So the question is how much time it takes for IntelliSense to find all the headers?
How the time depends on the number of files. So, for example, if you have a project with like 100,000 files,
Yeah, I don't have those numbers like off the top of my head, but also this also depends on not only the number of files, but also how they are structured as well. So we have to go deep into the directories as well. So you're talking about recursive, right? Recursive search, because if it's individual, it's more predictable. But if it's recursive, we don't really know how deep, how many folders are there, and it could take a long time if it was large. Especially if there are ambiguously named headers, like same name but different locations. That would be that's something you want to avoid by telling us the exact path. Like put that forward up front, so we resolve those first and make sure we get the right version. So in the future, we might do more UI integration to let you kind of, if we find multiple ones, and let you pick which one is the right one you want to use. But right now, help us by having that path up front. That would help us. Yes, you have another question?
Does it use the same IntelliSense engine as Visual Studio?
So the question is, does it use the same IntelliSense engine as Visual Studio? And the answer is yes.
Then on large projects, it will take a while to parse everything, and eventually you will need to clean the cache because it becomes too slow.
Yeah, performance is definitely something that could potentially be a problem for large projects.
By the way,
So that's why we have the recursive syntax as an opt-in thing, so you can decide wisely where to use it, and then help us by putting the known locations up front. But yes, you have another comment.
at least with the latest version of Visual Studio, I'm now using IntelliSense or Visual Assist. We just used to work together.
Okay.
It's performing well enough, even though it's software.
Yeah. So Visual Studio, the support we had before is MS Build projects, build system based. This is more like an open, what we call open folder scenario, which means it doesn't have a build system. It has very little knowledge about how your project is going to be built, right? It basically has no knowledge of it. So IntelliSense would need to find those information separately. That's also something Visual Studio is adding to 2017 support. Yes, another comment?
I have a project with a set of makefiles with auto tools, AutoCorn. Does Visual Studio Code support auto tools?
So the question is, does Visual Studio Code Code support auto tools? I'm not very familiar with those tools. Are there anything special other than like running a command, external command?
Yeah,
The idea can automatically launch certain file, which will generate the make files.
Oh, I see.
Depending on the configuration.
Okay, so you need to run those tools to generate your make files and then run
Basically, like
with the
CMake.
make files.
It's like CMake, isn't it?
I'm not familiar with CMake.
so using task.json, you should be able to configure command line tasks. Therefore, if you can do it via the command line, there's no reason why you can't do it from within Visual Studio Code. Yeah,
it's basically you just tell it what to do. The commands have it in a batch file or script file, and let VS Code run that.
Yeah.
Basically.
So by extension, it should be supported.
And if the command generates new files, those will pop up in the folder list.
Yeah, it does. The question is if for the generated files, do they get populated automatically in VS Code? And the answer is yes. All right, so for the next demo, I don't know what time is it. Okay, I'm gonna switch over to Windows. And the reason I wanna show you on Windows is because I wanna show you the support we just added for WSL, which is Windows Subsystem for Linux. Here on Windows box, I have basically the Ubuntu bash window running. So if you are targeting Linux, this will be an option for you to still work on a Windows box, but have a Linux environment to work with. So, yes, question?
Name GW?
No, this is a subsystem of Windows. This comes with Windows. This does not use VM technologies. This actually goes down to the bare metal. It's a real Linux system without UI. So you have a command line. Yes, you haven't said something.
So there isn't any sort of abstraction layer. It's not like you're running some kind of virtual.
Yeah, no virtualization.
Like NGW. So you can actually just turn on a developer setting and then literally download. There are like there's Fedora or Ubuntu and one other distro of Linux, and you can actually just run it and get started within about half an hour.
Or less. I always say less.
Yeah, or less.
So it's a feature that's part of Windows. If you go to Windows features, you can find that in the list and simply enable that feature. And this one I have downloaded. This is actually from Microsoft Store called Ubuntu something. But then downloaded, it's like running an app, but then you have a Linux environment to work with. So I have go ahead and install GCC on this Linux system. So I'm going to show you how VS Code works with that system. Visual Studio Code, very similar UI on Windows. What I have here is a very simple program, but the interesting thing is this app right now is targeting WSL with me doing nothing, no configurations, because we auto detect that I have a GCC compiler installed for my WSL system. I can prove that to you by go to definition. So let's just look at what version of IO stream file it's gonna use, right? So let me open this file, reveal in Explorer. Okay, so this is the version of that header, which is basically the version in the WSL system mapped back to Windows file system. That's why you see this long path here. This is mapping to my Ubuntu system on Windows, but then this is basically your Linux path to that. So on Windows, Visual Studio Code does a few things. We try to find a compiler, right? Like what we saw on Mac, we detect the CLAN compiler on Mac. On Windows, because there are so many different subsystems, and we want to support that, so our logic goes like this. We look for Visual Studio as the first option. If you have MSVC installed, we're going to use that. On my box, I currently don't have VS installed. That's why WSL is up as the second option. That's picked. And then we will follow, if you didn't have WSL enabled or didn't have a compiler installed, we'll move on and say, hey, seems like you have a MinGW installation, and we'll use that. If not, then we try to detect SIG1 as another option. And if we go through everything and nothing found, then you just have to do manual configuration. But by default, it should work pretty well with out of the box with these subsystems. Yeah,
So
If
question.
I start a project, like let's say I have nothing installed, and then I start a project and then I install Visual Studio. Will the project then suddenly pick up that, hey, I found the compiler now?
Depends on whether you have already opened it in VS Code. You have never opened it, then it's fine. It's going to detect on your first open. But if you have opened it, we probably had gone through that logic already. You might want to kind of clean the what the file we already generated and kind of reload it and have it redo this thing.
And that's actually available via the command palette. So you just have
Right.
to hit a hotkey and say, hey, I want to regenerate this, and it'll give you a completely new configuration
Yeah.
to work with.
Yeah, just simply delete the file you already have and regenerate. So for the sake of time, I want to finish my demo here. So I just showed you how WSL is detected by default. The second thing I want to show you is, let's go ahead and open this configuration file that we are very familiar with at this moment. So this is a default. I want to show you, this is a compiler we found on WSL. So I can go ahead and rename this configuration to be WSL, just so it's clear. What I want to show is how you can add multiple configurations. If you target more than one system, I don't know, it could be the same project you have for Mac, Windows, or Linux, or it could be a subsystem that you're targeting WSL or MinGW. You can easily add another configuration by doing this. So now, if I do this and comma and copy over and name this MinGW. Of course, now I'm gonna have to manually pass in the command because it's a different location. So on my system, I have MinGW installed right here, MinGW, Bing, and then I have a compiler here, right? So that's the path I'm gonna copy and paste in there, which is right here. I'm gonna do the quick copy paste here. And you see how we accept Windows style path and Linux style path, and we do the automatic mapping because of the different subsystems.
But you need to do the double backslash.
Yes, you do. Okay, so now we have two configurations. It's super easy to switch between configurations. Come here, that says WSL. Now I have two different ones. Now I can simply switch over to MinGW. See, we're on fire again because IntelliSense gets kicked off and say, hey, now I want to resolve everything in the context of MinGW instead. Now, once this is done, I can prove to you now we are targeting MinGW indeed by going to this file and open it in Explorer. This is using the MinGW version of that header file. So we can switch over between different systems really, really easy. Okay, so that's that demo. One more thing I'll show you. Something about VS Code itself is now we have seen all these features in VS Code, and the question is, what else do you want in VS Code that would, whatever tool you're using today, to at least give this a try, and what's stopping you from doing that? So one thing we hear pretty often is I'm used to some other tools, key map, like key bindings. I'm used to that workflow, and how do I do that in VS Code? And I have to learn all these new things and stuff like that. So to help with that, we actually have a number of extensions, which is right here, to help you map the key bindings from other editors. We have a big list of things from many different editors. So let me show you that real quick. So I have the Vim one, the Vim key map installed in here. Right now it's disabled. That's because once I enable it, it's gonna take over on my keyboard, and I'm not really a Vim user, so I can't really work with that. But now I have it enabled. We are completely in Vim mode at this moment. So what do? So I do H forward and go up line JK, W for moving forward by words, and then I can do O to start a new line and start typing. Yeah, stuff like that. You're completely in a Vim mode at this point. And we have key maps for other editors if you come from other background. So I just want to show you that. And of course, VS Code is really, really fully customizable, as I mentioned. I think I'm done with the demos. I can stand up now. Yes, question?
One question about key mappings and
Yeah.
things. I think this was an asked for feature in it. Keyboard macros, being able to, I don't know, start a macro, type a bunch of, open up a bunch of menus, do a bunch of commands, and then reproduce them over and over again. Is that supported now?
So the question is if whether keyboard macros is supported. I don't know.
Okay.
Do you know, Griffin?
I know that there is an interface for accessing the key bindings manually, so you don't necessarily have to download a package to change the way most of this works. I would have to do some research. I would imagine that there would be some way to configure how your test.json works. So just by mapping some key bindings to a specific task, that's kind of at least gets you most of the way there. I don't know about text editing specifically, but
more about
working within the editor, or
like when you want to reproduce some pattern of keystrokes over and over again.
Oh, I
see.
see.
Usually do this in Vim, but
Okay.
it's like those kind of things.
So that's not officially, so that would be more so the Visual Studio Code side of things. So Rong and I, we work on the C++ extension.
I see.
But we're happy to take that feedback to the team.
Absolutely.
Yeah.
Because we try to make sure to get back to people's feature requests as quickly as possible. We're always answering the GitHub issues and stuff like that.
Yeah, no, I like your guys' editor. It's a very good version of Sublime.
Okay. That's a compliment, I take. Okay.
I use Sublime quite a bit too, but it doesn't have keyboard macros either.
Okay. All right.
So I end up back in Vim all the time.
Okay. Is that the only thing? Sorry, is that the only thing that's missing? Otherwise, you would be in VS Code all the time?
Configuration is quite difficult at my work. I'm not quite sure. We use Visual Studio there, and
Okay.
I will probably continue to do so.
Okay.
I know that we do actually have people working on, I think it's about 12 million lines of code, and we do use Visual Studio Code on it.
Okay, good.
It seems to work okay, but I haven't been doing that full time. I've only used it on small toy projects.
I see. Got it.
What
Okay.
I would say is just consider, so if you're working on Windows, there's no reason why you can't do your text editing in Visual Studio Code and then do your actual debugging and heavy work inside of Visual Studio.
Which is, yeah, you have the,
Yeah, so I was wondering if you have any kind of like refactoring support or macro expansion, you know, which helps with evolving the code base, discovering the code base, understanding the code base, all that features.
Yeah.
Visual Studio has a lot of these. And we still need a lot more for C++.
yes. So the question is whether we have support for refactoring, macro expansion, and features like that, like what Visual Studio has. So the answer is we don't have those right now. As you can see, we are still like kind of finishing up the core feature set, but that's definitely something we have heard over and over, especially refactoring. Yeah, that's all I can say for now. It's on the backlog. It's something we have heard. Yes.
If VS Code is available for free, then what does it give to Microsoft? Why did Microsoft decide to develop this?
So the question is, since VS Code is completely free, what is Microsoft getting out of this? Excellent question.
What was the business case?
What's the business case? So when we started the project, the thought was really simple. Was we realized there are a lot of developers working on non-Windows systems, and we only had Visual Studio as an offering on Windows. So we are never able to reach to these developers. We're never able to have a conversation with these developers because they are not part of our ecosystem. So our first thinking when we started the project was really about how can we start a conversation with those developers? Like, how do we understand what they are trying to do? How do we help them there? So that's how it started as a cross-platform editor. And also because Visual Studio, how we position it is like a fully featured IDE. It has everything, all the features. But we know there are developers who prefer editors over IDEs because some people like lightweight tools, some people like heavy IDEs, which is all fine. So we want to provide both options. As far as business models go, Visual Studio is free as well. To some extent, we made the community edition free to small companies, students, hobbyists, and stuff like that. And we really just want to have developers in our ecosystem. I think that was the initial thought. Is once we have a connection, we have a conversation, we understand what you're doing, and there are things we could help. And then maybe we'll figure out something later. And we don't really actually make money off VS Code at this moment, as you can tell. It's completely free and open sourced. But yeah, the basic thinking was just to reach out to the developers and build our developer base and have a conversation with more customers in our ecosystem. That was the idea.
So if I may,
yeah, go ahead.
So Microsoft, over the last few years, we've definitely been transitioning over to being able to offer services for the developers that we form relationships with. Well, as it turns out, developer tools is a fantastic way to form relationships with developers. Say that they need some tool to be made for their particular application. We can have talks with them, and in doing so, we can talk about some of the other services that we offer. So it's more so like a win-win for all of the people who are involved.
Okay, so in summary, Visual Studio Code makes a great C++ development environment by leveraging everything VS Code has to offer, plus the IntelliSense and debugging and all these features we offer through the extension. So one more thing I want to mention about Linux development. I didn't have that slide until last night. That's based on the conversations I've had in the past couple of days. Is if I'm developing for Linux, is there an option for me to continue to use Visual Studio? And there is. With Visual Studio 2017, you can remote target Linux for C++ development. You get full IntelliSense, you get full debugging. It's the full power of Visual Studio IDE you can use for Linux development. So it goes into more details on the slide. The way it works is very, very similar to Visual Studio Code. Like it doesn't require like a build system. You can use CMake. We have out-of-box for CMake. You can bring in your own compiler, and you need a little bit of configuration, like the JSON files we went through. Very, very similar. But once you have that set up, you can connect to a remote Linux box. You get IntelliSense. You can full debugging using the Visual Studio debugger. So just as another option if you're targeting Linux. Yes.
So I have a question directly connected directly to that. The connecting dialog is very hard to find in the middle of the settings dialog.
Okay.
Somewhere hidden.
Okay.
That's hard to find. It
okay.
Should be somewhere more visible. That's a minor gripe. My major issue right now is that our system uses the gateway server to connect to the target machines, and this cannot go through that. So I simply cannot. What was
the issue?
Our connection is not a direct connection to the target machine.
Oh, okay.
It goes through a gateway server, which and then it needs to execute some commands.
Oh, I see.
Transfer to the target. So, is there any hope that we have support for that in the future?
When you don't have a direct connection? Yeah, we have to think about it. Yeah, so the question was two things. One was the connection dialog was kind of hard to discover. The second comment was the remote machine doesn't have direct connection with the development box, and whether that could be supported. Yeah. Yeah, we have to think about how we can support that kind of scenarios. Okay, you had the comment? No? Okay.
Actually, I have.
Oh, you do?
Someone asked for remote debugging in Visual Studio Code.
Yeah.
In case you need to, I have it. I figured it out. So.
Yes, we do have remote debugging in Visual Studio Code.
Yeah, it just requires you to configure the launch. Instead of running an application, you have to set it to attach to an application or to a port and so on.
Yeah, there are some intricacies to doing that with Linux. It's actually, so I work on the C++ extension for Visual Studio Code, and I use Visual Studio Code in order to do that. So I'm actually debugging the extension using Visual Studio Code.
Yes.
So yeah, I do have a little bit of experience with that. So basically, if I were to try to debug the C++ extension, I would open up a window of Visual Studio Code that has the newly built binary running. And then for my other instance of Visual Studio Code, I then attach to that process, and I can actually see what's going on.
Yes. That is supported. Yes, go ahead.
One thing I find a bit cumbersome is adding all the include paths manually. While usually I have CMake projects that already know where all the includes are. So
yes. So the question is, adding all the include path for IntelliSense is a bit hard and too much work, and you already have CMake in there. Why can't we use that? I was wondering why nobody asked that question, because I added that in my slide last night. Is CMake support? So things we already talked about. I just kind of summarized there for watching afterwards. But right now, in our extension, we don't have IntelliSense support out of the box for CMake. What we do have is the last bullet point there to support compartments.json file, which is a file you can export using CMake. So as part of your CMake build process, just passing additional flag. As it builds, it will generate additional file, that's this name. So that's all we need for IntelliSense. So in the setting file I showed you in there, which is this guy over here. And you can simply just pass in, let's see. Oh, I'm in Vim mode. God. Tell me how to work with that. I'm just not used to that. Okay, that's file, and then just go here and say use compile commands. That's the property you need. What you do is pass the full path to that file, and we will use that for IntelliSense. So that's the kind of the approach for the time being. But CMake support is definitely something on the radar.
Is it possible for an extension to modify the include paths of the C++ IntelliSense? Because that way the CMake extension that exists and is quite nice could actually populate the file correctly, but I don't know if that's allowed or not.
Yeah. So the question is, can the extension modify the settings file for IntelliJ for the include path, right? I believe that's what the extension does. The CMake tools extension basically overrides our JSON file. Yeah, it does work that way. So that's another option for the time being, is if you want to use CMake. Yes.
If you go back to your IDE, I saw something down there about Azure.
Yes.
So maybe there is a monetization thing in there for what sort of cloud services are at least maybe supported or something for this?
So the question is, what kind of cloud services is supported in VS Code? So VS Code itself doesn't provide any of those things. What it does is like this extension here called Azure Storage. What you do is once you have your Azure account signed in here, it has a connection and read information from your storage account back into the IDE and tells you, hey, these are the, I don't know, what tables or queues you have in storage. So as a way to view what you have in the cloud. But there are many other extensions that would enable different Azure services. For example, there's a Docker extension. So if you want to build a Docker image, that extension allows you to view the Docker images you have built and upload it. So stuff like that. So right now it's basically UI to view what you have in the cloud. We are looking at different ways for how we can help developers to kind of, if you have a cloud need, like push things into the cloud, how we expose those commands through UI. So that type of thing. Okay, so we are almost running out of time, but I have something important I want to show you. Let's go through all that. And the call to action, install VS Code and the extension if you haven't already. But this is what I want to show you, is 2018, this year, is our 25th anniversary of Visual C++. And it's pretty cool if you look back in the history. What Visual Studio versions we have shipped over the years, all the way back to 1993. This is when Visual C++ 1.0 launched. And I actually have a video there.
Back then, programmers worked
Okay, there you go. Full-featured, really professional C++ Windows application in minutes. Ladies and gentlemen, that was Visual C++.
So that was Dennis Gilbert, and I believe he was the dev manager on the team back then, and he announced the launch of Visual C++ 1.0. So 25 years later, we find the t-shirt design, that the t-shirt he was wearing, the purple one. I don't know if you noticed. We reprinted a bunch of the t-shirts, and I brought over some to Aspen and have them in my suitcase. So feel free to grab one after the session. I should have enough for everyone in this room, and you may be able to get to choose the right size as well, because I different sizes. Anyway, so, whoops. No, I don't need to listen to that again. I know we are out of time. Happy to take any other questions afterwards if you have any, but thank you so.
Can you show the link to start exploring?
Oh, the tool? Oh, yeah, yes.
So leave it on the screen?
Yes.
Also,
Here.
as a heads up, we are partly open source. So if you want to contribute, you can just find us on GitHub at MSCode. Let's see, what is it? VS Code CPP tools.
Yeah, it's the last one. Yeah, github.com, Microsoft VS Code /CPP tools.
Every single day, basically.
All right, thank you so much for coming, and feel free to grab a t-shirt.